We have a new graph, and this one obviously isn't one of the graphs that we know. It's just a bunch of straight lines being put together. And now we want to sketch the graph of g of 0.5x. This time, the number that's different is the 0.5, and you can see that that 0.5 is inside the function. Inside the function means that you're going to multiply x by something. And 0.5 is the same as a half. So sometimes it's nicer to use fractions than it is to use decimals, because with things that happen inside the function, we multiply by the reciprocal. So the fact that there's a half inside means our x values are going to be multiplied by 2. If we were going to describe this, we would describe this if you wanted to have really lots of detail, we would call it a horizontal stretch by a factor of 2. That would be how you would describe it in words. So it has been stretched. Same thing as with vertical stretches and compressions. You're going to use your y-axis. When you stretch things, you're going to kind of think like an accordion. You're just going to pull away from the y-axis. Anytime that you have a horizontal compression, you're going to squish things towards the y-axis. And this one, we do have some things to the left and some things to the right. So we know that x has to be multiplied by 2. We have 4 key points on this graph. So if we label all of those points, we have -3, 2 going from left to right. We've got 1, 5, 3, 3, and 4, -2. So again, the scale on this graph doesn't go by 1s horizontally. It's going by 2s horizontally. So just be careful with that. We will put the arrow for each of these points, and above this arrow we describe what we're going to do. In this case, we're going to multiply our x values by 2. It's just a nice reminder to check that. Yes? Because if the inside is a half, this number right here is always the reciprocal. So we take whatever number's inside and we flip it. So 1 over 2 becomes 2 over 1. If we just had, we're going to see somewhere there's a whole number in there. Let's say it was g of 3x. Then you would, 3 is like 3 over 1. Then you would multiply x by 1 over 3. So you always take the flip or the reciprocal of that value. And so now each of our y values, since we're multiplying by x, our y values are not going to change. So I can, this time I'm going to write them all in. Sometimes you'll go point by point, and that's fine. This time I decided my y values aren't changing. I'll just write them all the same. Sometimes that's nice because you're going to be doing a lot of mental math, and it's going to be easy to make a little mistake. So the math is easy. Multiply by 2, right? Some of you are going to do this because you're not going to think. What did I miss? Negative. The negative. But it's such an easy mistake to make. And you make easy mistakes when you're doing something that is what you think is really easy, because you're starting to think about the next thing already. So be careful. Check things as you go. Even though it's easy stuff to do, we're just multiplying the x values by 2. But do a quick check to make sure that your simple multiplying and simple arithmetic is good. We're going to draw those points on now. -6, 2. 2, 5. 6, 3, and 8, -2. And think about that accordion kind of thing. Have we stretched things away from the y-axis? Does it appear that that's the case? the more it stretches. Yes?
One thing is to be 1,5, you put 2,5, right? But you picked negative.
Oh, yes, thank you. See how easy it is to make those little mistakes. This 1,5 should have been negative 1,5. And then this should be negative 2,5. But I already knew what the graph, so I labeled it wrong, but I knew where it was supposed to be, so I ended up having my graph right in the end. Okay? What happens on your final exam if you make those silly mistakes? They still take off a half a mark. My graph was right on the end, but my work had a little mistake in it. You're still going to lose a half a mark. So it's really, the final exam, I'm going to tell you, it's really, really picky. And it's super easy to make those tiny little errors like that. So it has been stretched out by a factor of 2. This one we don't know the equation of, so we can't do the same thing as before. But the question, well, yeah, we could, but it wouldn't be pretty. Some people might say that, yeah. So we got 4, 8.